Okay, well, welcome everyone to a joint workshop being held with a team from Amazon AWS and Flower Labs. Um, it's our pleasure to be examining really powerful use cases in the world of enterprise federated learning. And specifically today, we're going to be talking a lot about finance and healthcare use cases that can be enabled when you combine Flower and AWS. And so I'm delighted to be joined here today with experts from both organizations. And let me just proceed here. So again, the purpose of this workshop is that we noticed that there was an increase in demand and interest in deploying enterprise-style federated learning. In particular, the use cases we were asked questions about. So with the folks from Amazon that are here, or the folks from Flower that were here, we were asked a lot of questions about how do we set up and deploy federated learning in the situations of finance and medical use cases. And so we've known the people here at Amazon for quite a long time, collaborated with them on various different types of partnerships with organizations who are rolling these technologies out. And we felt it was time to give a workshop. This is the second workshop we've given recently. Our first workshop was back on Friday. That was given in Chinese and in the Chinese language, and actually included a physical component. And so folks came to the Amazon AWS offices in Taiwan and to meet the folks there to discuss their use cases. And then today we want to follow up with a session that's exclusively in English with a slightly different time zone to make it easier for people to attend from different parts of the world. So I just want to hand over to Nadia from Amazon AWS to let her say a few words about the workshop and her interests.
Thanks, Nick, and hello, everyone. I'm Nadia, the Financial Service Account Manager from AWS Taiwan, and I would like to extend my sincere thanks to the Flower team for the invitation and to all of you for joining us today. And our AWS Taiwan team will introduce how AWS could play a crucial role in leveraging the federated learning. And as you all know, the federated learning is emerging as a key technology for managing distributed data while ensuring privacy. And currently, our financial service clients in Taiwan are also exploring how federated learning can be applied to the fraud detection and claims risk assessment. And AWS is at the forefront of providing the necessary tools and infrastructure to implement the federated learning. And our scalable cloud infrastructure supports the needs of the federated learning. And whether you are training models across multiple institutions or managing large-scale data sets. So additionally, our machine learning service, Amazon SageMaker, facilitates efficient model building, training, and deployment while maintaining the data privacy. So thank you again for joining us today. And our solution architect, James and Ray, they will demonstrate how AWS can enhance your federated learning project on AWS. Thank you, Nick. And so hand up time back to you.
Great, thank you. It certainly is exciting times, I think, for federated learning. And we've seen Amazon and Flower software and the services work so well together. Let me just show the folks the workshop agenda. And so what we've done is that each of the experts that are here with us, they're going to give talks on different dimensions to this topic. We're going to have, for example, a talk that looks into what is federated learning, if you're not familiar, and then what is Flower as a framework. We're going to have a talk about specific scenarios that we've seen built using Flower or using AWS in the domains of financial and medical use cases. We're going to hear about how federated learning can be deployed really easily, really powerfully using Amazon services. And then we're also going to hear how the Amazon SageMaker you just heard about can work really well with Flower towards starting to build these use cases. And at the end, we're going to have some Q&A, but in between these talks, we'll give you a chance to ask some questions too. To ask questions, you can raise your hand and I'll mute you, or you could ask questions on our Slack. I'll be monitoring that. Also, there's a chat facility in the Zoom webinar, so I'll be looking at all 3 locations and then posing your questions, or unless you're asking it yourself, to our experts. But this is the agenda that we've arranged for you today. Before we dive in, let's look at who these experts are. And so you've heard from me a bit so far. I'm the chief scientist at Flower. We've also heard from Nadia. She's introduced herself. She is at AWS, doing a lot of business development and managerial roles. And now let's look at the experts that we have, the people who really know the information to tell you today. And so from the Flower team, we have Pan Hang. He is a research scientist. He's going to give us our first talk. He is joined by Yan Gao, also a research scientist. He's going to be diving into these use cases. They're going to work together with Ray Wang. He's a senior solutions architect at AWS, and James Chan, a partner solutions architect. And so these 2 gentlemen are going to talk about, as I mentioned, SageMaker, and about how you can use the AWS services when you're rolling out federated learning, particularly for enterprise scenarios. So we know the team now. We know what their workshop's going to be. So let's get started. I'm going to hand over to Pan, who's going to give us our first talk. So over to you, Pan. I'm really excited to see what you're going to tell us today.
Cool. Thanks all for the kind intro. So let me share my screen. Full screen. Cool. Can you guys see my screen?
Yes, looks good.
Cool. Hey guys, I'm a research scientist from Flower Labs. My name is Pan, and please follow me to the world of federated learning and Flower. And so speaking of federated learning, mainly, well, I think it's a very good naming because it's mainly about federated and learning. So when I talk about federated, it's a joint effort of all the participating parties. So they wanted to train a joint model to do machine learning without sacrificing their privacy. And this is actually a very heated topic, and feel free to join us on Slack channel. We have nearly 5,000 practitioners in the channel, and feel free to reach out and join us. And I believe most of us are very familiar with centralized machine learning. When we do centralized machine learning, we need a central server, and we need to collect all the data from all kinds of devices. Basically, we need to collect those data from our users, from our customers, and put them together into a single place, which is our central server, and use the data to train a model. But that not always works, because many of the users and customers are very reluctant to directly share their data, not only because of privacy, and also because of some compliance issues, like hospitals and banks. They cannot directly share those client data or transaction data with a third party, otherwise can lead to some legal problems. And to solve those restrictions, years ago, Google first proposed federated learning. The main difference is that previously, when we talk about centralized machine learning, we need to collect all the data and then train them in a single place. But now, in federated learning, the training happens on the client side, which means the training itself is distributed, which perfectly match the distributed feature of the data. And we have already used federated learning in our real world a lot. For example, the personalization of speech recognition. We have some sort of speech recognition at our home, maybe, And for those things, if you wanted to have more personalized interactions with this AI assistant, they need to train on your own data. But obviously, not all our audio data will be sent to a cloud server. Most of the time, they can be trained locally and fine-tune the model to improve the experience, the interaction experience. And also, like many keyboard, for example, the Google board, they also use federated learning to make the next word prediction. And obviously, the words we type every single day is highly sensitive, and we don't want to share everything we type to Google. So what they do is to use federated learning to train a next word prediction model locally on our phone without collecting our data. We also use federated learning in robotic perception. And also, there are many cases of cross-silo. That's basically means the collaboration between different organizations and companies. And it allows us to sharing, not physical sharing, but just about, but it's more like using those sensitive data distributed across different organizations to train a joint model without physically sharing those sensitive data. So the data never moves. And actually, this is already used in many industries for both model training and analytics. Here's some federated learning examples. For example, in the finance industry, they use federated learning to enhance their anti-money laundering model, and also to judging the mortgage eligibility, also to do the risk scoring, to identify potential risks associated with certain debts. And also use federated learning is also applied in insurance pricing and assessments, because to pricing insurance, you need to access users' sensitive data. And obviously this data, although they are very sensitive, but it will help with the pricing. And also federated learning is used in decentralized finance and supply chain financing. Similarly, in the health industry, because health industry is also very sensitive, it's also very data sensitive, and all those medical data can contribute to a better prediction model and diagnosis model. But all those patient data are under strict regulations, and they cannot expose those data to any other parts. And federated learning then becomes a very good tool for the health industry. They use it for medical image analysis, disease prediction, and personalized treatment. And also they use drug discovery and used to forecasting the pandemic and monitoring COVID-19 and screening COVID-19 tests. And also it also utilize the electronic health record to train a better model. We have a few real-world cases here. The first one is the banking circles. It's a financial company deals with mainly focusing on the cross-border transactions, and they use federated learning to improve the anti-money laundering model. So they can use both the data from the US market and from the Europe EU market. And they also tried our Flower framework, and they like Flower very much. And also for Swift and Microsoft also work together to use federated learning to combat financial crime, because for those cross-border financial transactions, many of them might be fraud transactions, and to accurately detect those potentially suspicious and potentially harmful transactions, Swift need to collaborate with banks all across the world, and obviously it is not that possible to directly collect or transfer the bank client data from one country to another. And similarly, a UCL research team also uses Flower to improve and build a better claims frequency prediction model. because for the insurance companies, the more data means the more accurate pricing and more accurate prediction, so they can make more money. So naturally, the need to include more data to have a better training, to have a better model. And for each single insurance company, they don't have enough data. So federated learning become a very good tool to help them pull all those data together to train a better model. Also, the Oxford University works with NHS to develop the COVID-19 screening model to make the COVID-19 screening way more faster, because previously they need hours, even days to get the result. Now, if they use federated learning to build a better screening model, it makes it way more faster. And when talk about this, people may ask why we need federated learning, and the benefits can vary depending on the scenarios. But first of all, is federated learning can guarantee user privacy and also helps with the compliance. Because in many industries, if we wanted to do compliance, like for banks, they need to fight against money laundering. But if you wanted to detect those money laundering and suspicious transactions, you might find that some user privacy regulations prevents you from having better and more accurate predictions. And federated learning can help you to reduce the restrictions and also to improve the model without violating those laws. And obviously, it is always a very good chance to train the model without sharing the data, because even if you can collect the data from users or from all other participants, data sharing agreement itself can be complex, especially when we talk about the data sharing agreements between organizations, because for sometimes they even need a third legal party to participate and to deal with like the collection of the data, the process of the data, and the cleanup of the data. So it's very complicated. But now these things are all solved by federated learning, and also it helps us to utilize all the data from all the edge devices, because edge devices often contains very sensitive data that is not currently used by us. But those data can also be useful and contribute to a better model if we consider using federated learning. Similarly, corporations can also, the institutions and companies can also benefit from federated learning, because previously, if you wanted to collaborate to train a machine learning model, that means those companies and institutions have a relatively high level of trust among them. But with federated learning, once all the user privacy or the data privacy of all the participating parties are guaranteed, the collaborations between those competing companies become possible, and also largely lower the trust requirements between those large organizations. And finally, this also means that using federated learning also means that we can potentially use different system configurations, because because we can use distributed algorithms for those distributed data. And also it lowers the requirement for the central infrastructure, because previously we need a central server for collecting, storing, and training the model. Collecting the data and training the model. But now we just need to do some basic computation on our central server, because the training happens on the user device. So a large opportunity the federated learning brings is that for now, when we talk about machine learning and AI stuff, they have already makes huge influence. But actually, the data used is most likely is public data and centralized data. But that's just a tiny bit of all the data we have on this around the globe. And talking about the unused data, most of the data are sensitive and distributed, and those data are not that compatible with the way of training of the traditional way of training a machine learning model. But with federated learning, we can unleash out of those unused data, because federated learning is about to use all the data available. Then how does those benefits come from? So let's have a deep dive into the federated learning. So first of all, when we first talk about the difference between the federated learning and centralized machine learning, we talk about that the goal of the federated learning is to protect the user privacy and make the training happens on the client's machine. That means the data never goes out from the client device. So in a typical federated learning loop, first of all, there's a cloud server that initializes a global model and then shares the global model to all the client devices. Once each device receives the global model, we will build a local model using, basically it's the same thing, but this uses some parameters received from a central server, and each device will build its own local model and trains the local model on its local data. And then we'll get a model update, and those model updates will be sent back to the cloud server. The cloud server will aggregate those model updates and improve the global model. And then it can continue round after round. So we can iterate on the global model and get better and better. Each communication round, if we talk about like cross-device cases, we normally sample a random set of clients, not all the clients are sampled, and then we can run some algorithms like SGD locally, and then the server will average the model updates. And throughout this process, we can add privacy mechanisms to further provide to even provide better user privacy guarantees, including like secure aggregation, differential privacy, and multiple encryption. And we can also reduce the communication by performing local updating, and also to sample a subset of devices, a smaller subset, so we can save some communication costs. And the most typical algorithms in federated learning is the federated averaging. The first of all is to initialize the local model parameters W0. And then in each round, we will randomly sample M clients. And the global model parameters will be broadcasted to these clients. And for each of the clients, they will do a client update, which means they will use those model parameters to build a model and then train the model on its local data and get model updates. And finally, those model updates will be sent back to the server, and the server is able to compute the weighted average of all the model updates, and then get a new model. So, and then repeat round after round. And but of course, the federated learning doesn't really solve everything. We still face some challenges when we talk about federated learning. First of all, is although we have massive amount of unused data, but not all those data are labeled. And for example, when we take a photo like a cat or dog, we'll never manually input and tells our phone that, oh, I just took a photo of a cat or dog. We just took a photo and do nothing else. And also, those data are non-ROD, which means the data distribution on each device can vary significantly. This is because each user might generate very different data because, well, based on the different behaviors and preferences of each user. For example, I love to take photos of a cat, and some other guys love to take photos of a dog. So I have lots of dog photos, and we have cat photos, and that means the data are very different on my device on their device. And also, some users generate loads of data each day, but some of people don't really generate any data. Like some people love to use Instagram, and they take photos, like hundreds of photos each day, but I don't really use Instagram a lot, so might be I never really take a photo. I take less than one photo each day, so that means that the data is unbalanced on each device. And these data are massively distributed. When we talk about the massive amount of data, you must notice that it also means that it is massively distributed because we have billions of devices across the globe. So that means that the amount of data on each single device can be like a relatively small amount. But if we consider the number of mobile devices we have on this globe, it can be a massive amount. And also, each single device. When we talk about mobile devices, we have billions of mobile devices, but the communication capacity are limited because for most of them they use mobile network, and mobile network is not that reliable. It can lose connection anytime, which means a client can easily drop out during training. And lastly is the device themselves are very different. They have different computing resources. For example, a very advanced phone and a very old phone, they definitely have different capacity on training those models. And if we consider all those factors together, you might find that in each federated learning round, the average time for a single federated learning round can be determined by the slowest and worst device in the training. So this can be like stragglers, and potentially makes the federated learning training way slower than expected. And finally, it's privacy and security issues are not solved directly by federated learning because of more advanced attacks towards machine learning model itself. And in federated learning, although only the model parameters are transferred back to the central server, but just from those parameters, attackers can manage to reconstruct the user level samples. Or even if they cannot reconstruct that with that accuracy, they can still try to infer something from the model updates. For example, they can infer whether a patient exists in the database of a specific hospital or not. And Flower has a very vibrant community and a very large ecosystem. So we have there are developers all across the globe who love to use Flower, and we have more than 100 contributors. And we rely on those open source contributors to make our framework better and better. Also, we have a leading system. You can basically use all the tools with our framework, including PyTorch, TensorFlow, Android, and Hugging Face. And Flower also works with a bunch of other platforms like AWS. You can, speaking of Flower code, you can run the Flower code in Flower simulation engine. And also you can deploy Flower code on AWS and also on like Raspberry Pi, just Nano, all those edge devices. And also we provide many Flower example projects. So if you wanted to find some code to either get started with and wanted to check if there's any existing code, then you can check our Flower examples page. We also provide Flower benchmarks for our researchers. So you can easily use those benchmarks to compare your algorithms with others. And also we have an additional tool named Flower Datasets. I highly recommend this library because largely alleviates the efforts to manually partition a dataset for research purposes. Flower also provides many strategies, which basically means FL algorithms, like Fed average, Fed plots, async Fed average, and Q-Fed average. And we use gRPC for the communication, which means that our framework is agnostic to the programming language used and the platform you're working on. We are open source framework and we are community driven framework. For now, we have 1.8K GitHub stars, and welcome to also give us a star on GitHub. And every year we also have a Flower AI Summit, and this is the photos from the last summit. And it's a super popular and welcomed event, and feel free to join us next time. So I won't go to the code details, but I just want to show a quick demo about get started with Flower within a single minute. So let's go to the code. Here I opened a empty VS Code, and I've already installed Flower, so I won't install it again. This is the latest Flower version. And to get started with Flower, what you need to do is just to Flower FLWR new, and then provide the app name. For this one, I can call it My Flower Project. And put my name here. And you are allowed to choose a bunch of templates to get started with, like, for example, the PyTorch, TensorFlow, sklearn, Hugging Face. We also have like Flower Baseline and Flower 2. And for this demo, I'll just use the first one, which is the PyTorch one. You can follow the instructions to get started quickly. But for this demo, I've already installed all the dependencies. So what I can do is just to use Flower run my Flower project. So you can use Flower run to pass the path to the Flower project you just created. Then press enter. So training has started. By default, we'll use our Flower simulation engine to train the model. And when we use Flower new, it actually automatically creates a project like this. It contains a Flower app.py, server app.py, and task.py. And if you are interested, feel free to take a look into the details. And we also have tutorial videos on YouTube. And then comes up. Yeah, we already round 1. And this comes from the simulated clients. Round 2, sampled 5 clients for training and sampled 10 clients for evaluation. Each round, enough for 3 rounds. I just let it run for 3 rounds. You can see the distributed loss is going down round after round. And that's it. And let me know if. And finally, please follow us on YouTube and Twitter, and also on LinkedIn. And also feel free to give us a star on our GitHub channel. And highly recommend to join us on Slack. There's a very vibrant society. So basically, you can find many people working on the same topic, and it's easier to connect to other practitioners in this channel. We have nearly 5,000 FL enthusiasts in this channel. Feel free to join us.
Great. Thanks, Pan. This is a really good introduction to Flower. And we have time for, I think, about, 5 minutes, 2, 3 minutes of questions before we go to the next talk. So if anyone here wants to ask a question, you can ask it in the webinar chat, or you could raise your hand and I'll mute you. Otherwise, I'm going to just look around to see what questions were posed while you were speaking. Let me see. One question here, I think you covered this, but it's a question from someone says, can Flower support differential privacy?
Yes, we do support differential privacy. We have a few strategies for central differential privacy and also for the local differential privacy. And we also have some examples and tutorials for how to use differential privacy in Flower. So just go to our documentation and search differential privacy, and you'll find there's some tutorials and also example code.
Okay, great. Let me see if anyone else has something else. I think I saw something in Slack. I guess once just a clarification. So even though that Flower is open source, the question is, can a company still use it and build on it commercially?
I think they can, right, Nick?
Yeah, that's
yeah, definitely they can.
Yeah, they can. We have many companies right now using it for mission critical stuff, for enterprise class types of deployments, and we even have a number of startups and smaller companies building, their whole venture, their home company just on top of Flower, where the business use case that they're trying to exploit is requires federated learning. So yeah, that's correct.
I think we also got some questions from our Zoom. So, can we implement our own custom logic before connecting the client and server? Well, the answer is definitely yes. And so I suppose the custom logic means the behaviors of the client and the server. That's definitely okay. You can customize your own strategy and pass that strategy to Flower. And by passing a custom strategy, which means you will have the full control of how the results are aggregated, and also how the clients train those models. So it's definitely possible to custom those logic.
The gentleman also, Mansell, but also asks, how robust is the FL library in terms of customization for authentication? Build another layer on top of Flower. So I guess I can answer this one. So we have other organizations have built their own authentication scheme into Flower when they happen to use a different one internally. So essentially, because Flower is open source and it's quite extensible, we can think there are a number of organizations that have integrated their own systems for authentication, but also networking and other types of customizations into the framework. And if you have questions about that, we're happy to help people through that process to the degree that they need. We better start moving on, I think, to the next talk. So thank you, Pan. Sure. It's a great talk.
Thanks.
Let's hand over to Jan Gao, who is also a research scientist at Flower. He's going to tell us more about the use cases. So he's taken a few use cases in the space. He wants to share them with you. Over to Jan.
Yeah, thanks for the introduction. Yeah, I'm Yan and also doing research scientist at Flower Labs. So I'm gonna share some Flower federated learning use cases for the finance and healthcare or medical. So as we mentioned, Flower has been used for many finance and healthcare applications. So for example, the finance applications include like the anti-money laundering, the insurance pricing and assessments, and also like judging the mortgage arguments and like the risk scoring and so on. And as for the medical examples, it involves like the disease prediction and diagnosis, and also like the drug discovery and development, and medical image analysis and so on. So yeah, lots of company and organizations have already developed and deployed FL for these applications, such as the Swift, the Banking Circle, Capital One, and NHS. And many of them built their FL system using Flower. So let's just pick some concrete use case and talk about more details. So first, let's say the finance use case using Flower. Before we look into the examples, so let's first check out the characteristics of financial data. So the data from the finance domain is sensitive and private, and the financial institutions handle highly sensitive data that must comply with strict the privacy regulations. And the finance also involve the data silos, which means the information is isolated with different departments or organizations. And also it has the requirement of the fraud detection. So the detecting fraudulent activities requires analysis and analyzing the patterns across multiple data sources. And on the other hand, it also has the requirement of risk management. The accurate risk assessment models are crucial for like the financial stability. So considering challenges and the requirements in finance, so federated learning provide a potential solution for it. So FL ensures that the data remains local and significantly reducing the risk of data breaches, and also ensuring the compliance with the regulations. And also, FL breaks down these silos by allowing collaborative model training without the need of centralized data, so enabling better like insights and decision making. Additionally, FL allows financial institutions to train models on a broader set of data from various entities, improving like the detection and prevention of fraud with more like comprehensive and accurate models. And finally, by using FL, the financial institutions can develop more like robust risk models by integrating diverse data sets that enhance the prediction of like the market trends, the credit risks, and investment opportunities. So, all right, so let's see the first financial use case. So one company that has publicly talked about their use case of federated learning in finance is Banking Circle. So at Flower Summit 2023, Robert Noville from Banking Circle shared their work on federated lending for anti-money laundering, AML. Yeah, so Banking Circle is a fully licensed next generation payments bank. So that meets global banking needs of payments, businesses, banks, and marketplaces. And through their API, so they offer fast, low-cost global payments and banking services by connecting to the world's clearing system, enabling real-world liquidity movement for all major currencies securely and compliantly. Yeah, so in his talk, Robert shared that the Banking Circle is revolutionizing corresponding transactions by building a super correspondent banking network, and they aim to cut the transaction times from 5 days to 5 seconds, and the cost from €50 to 50 cents. And taking the intensive and costly process of anti-money laundering, they have developed AI-powered transaction monitoring system. And however, this system faces challenges in US market due to the difference in transaction types and also the data transfer difficulties. Yeah, so let's see how they build a federated system using Flower to overcome the challenges. So he shared that the Banking Circle used FL to train the AI model on the European data without moving it across the borders. So this allows them to develop a model tailored to the US market, and it improves the accuracy and efficiency over time. And as the US model evolves, it feeds improvements back to the European system and benefiting from both regions. And yeah, the initial testing of the federated lending approach shows a significant performance improvements, including like a 65 increase in precision and a 55 increase in recall and 10% increase in accuracy. So showcasing that the success of Banking Circle's solution. Yes, so as the senior data scientist at Banking Circle, Robert Noville said, Flower was exactly the solution they were looking for to solve the money laundering problems. Right, so if you're interested in looking into more details, feel free to check out the YouTube video for Robert's talk at the Flower Summit 2023. Okay, now let's see the second finance use case. So it's federated lending for financial statements audits. Yeah, so the digital transformation has significantly increased the volume and the nature of data available for audience. And the use of advanced analysis techniques such as the deep learning can process this data efficiently. And in the field of auditing and financial services, protecting the privacy and confidentiality of the client data is very crucial. And federated learning FL provides us the method that that is compliant, secure, and efficient for handling the the sensitive data and making it highly suitable for the finance audience. So that requires high level of privacy protection. So yeah, let's take a look to the details regarding how to use FL to train model for financial statement audience. Then, and this paper was published at ICAIF 2022. And if you look at the figure, which shows the FL training on the audit data, and you see that the audit client keeps their data locally and train the client model on the data origin. And for the model architecture, they use an autoencoder model. And after the local training complete, the model updates are sent to a central server. And just note that they only transmit partial model weights in the middle of the autoencoder because they believe that this part of model weights may contain more general information across the clients. And then they aggregate the partial model weights on the server and send back to the client to start the next round of FL training. And after the training done, they use a pre-trained global model to initialize the client model and run inference to test the model performance. And yeah, so this people use Flower to build their federated learning system. And the federated model performed well on the anomaly detection without compromising the data privacy. And this research helps audit firm utilize the advanced machine learning techniques while also adhering to the privacy regulations and also potentially leading to more effective and efficient audience. Yeah, so let's move on to the third finance use case. So it's FL for the insurance industry. So yeah, there are some unique challenges in the insurance data, so such as is a scarcity and higher regulation surrounding its use. And the federated learning provides a solution that complies with the regulatory requirements and enhance the model performance while also safeguarding the data privacy. So these advantages make federated learning our ideal choice to handle the sensitive and regulated data, especially suitable for the insurance industry. And let's see. So this paper, as an example, which is published at SSRN 2024. So in this paper, the author proposed the FL framework to train a claims frequency model, and especially tailored for the insurance sector. And this type of model is commonly used in the insurance industry to predict the frequency of the claims made by the policy holders. And this helps the insurance company forecast the potential future claims, and therefore the better managing the risks and determining the premiums. And the findings show that the FL achieves similar performance as the traditional methods where the insurer share all their data. Yeah, so as a co-author of this paper, the Dylan mentioned that this paper also used the Flower to train their claimed frequency model in federated way. Okay, so now let's move on to the medical or healthcare use case. Yeah, so the same story. The healthcare data is highly sensitive and private, and it contains the information from the patients. And the healthcare data is dispersed across many institutions, and individual organizations often lack the sufficient data to build effective models. So federated learning in healthcare allows the machine learning models to be trained without transferring the medical data to a central server. Instead, the medical institutions train the models locally, and this mitigates the numerous security concerns by just remaining sensitive data locally, and also enabling collaborations among multiple medical institutions. Yeah, so now let's see use case, which is about the AHS using Flower to build up a COVID-19 test system. And this example was shared by Andrew Thornton at Flower AI Summit 2024. Yeah, so AHS here stands for National Health Service in England, so which has recently been facing numerous reforms. So as the article published in here, the Financial Times discussed that that the question raised, can better data save the NHS? So the NHS in the UK is experiencing the impact of the data transformation. Traditionally, the data analysis and the model training is undertaken by a third party university or companies. And the hospital just transferred data to the third party companies and certain agreements. And this practice can compromise the patient's data privacy, and is sometimes just not permitted. Yeah, so let's see a practical case of how federated learning was used to address this challenge. So around 2022, a British hospital faced difficulty with the COVID-19 and testing. And the traditional PCR test for COVID requires 3 days and cost around £40 each. So this is a significant expense for the AHS. And Andrew and his team proposed using federated learning and the patient tubular data for preliminary COVID-19 predictions. So this significantly reduced the cost. And this federated learning model was trained on data from 130,000 patients. Yeah, specifically, the model was trained using Raspberry Pi. And these devices, which is already programmed and well configured. This distributed to the hospital, and then the medical staff just upload the data directly to the devices for the model training. And the performance of the federated model trained with the data from the multiple hospitals is far exceeded that of the model trained with data from a single hospital. So the federated model reached the accuracy rate of over 80%. And such accuracy level is considered like acceptable. Yeah, as Andrew Sultan said, they use Flower to build their new COVID-19 test system. And if you're interested in looking into more details, so feel free to just check this YouTube video for Andrew's talk at Flower AI Summit 2024. Yeah, so that's all content that I want to share today. Flower and FL has been used for various applications on finance and the medical fields. And if you're interested in talk about more regarding FL, just feel free to scan this code and join Flower Slack. And if you have any questions about this talk, I'm happy to answer. Thank you.
Thank you, Jan. Very interesting talk. We can take a couple of quick questions from the audience, so feel free to post them in the Q&A or the webinar chat, Slack, or raise your hand and I can unmute you. I'll do the same thing as before and just take a look to see what sort of questions we've got. Oh, one question was, where can they find that talk you mentioned about banking circle?
So it's if you want to watch the YouTube video, is in the Flower YouTube channel, and just maybe searching for the banking circle. So basically, it's the talk that Robert gave at Flower Summit 2023.
Ah, I see. Okay, cool. Someone was looking for that. Yeah, I don't see anything else. Okay, cool. Well, thanks, Jan. We'll move on to the next talk.
Okay, thank you.
Great. Well, our next speaker is from the Amazon AWS team. We have James Chan here to talk to us about the deployment of a federated system when you're using AWS services and technology. And so great. Thank you for being here, James. Over to you.
Okay, I'm sharing my screen. Yeah, thank you, Nick. So hello, everyone. Thanks for having me in this session. And my name is James Chen. I'm Solutions Architect in AWS, and I'm based in Taiwan. Today, I am delving into the fascinating world of federated learning for AI. This is a groundbreaking approach in AI and machine learning. So this technology allows to harness the power of distributed data while maintaining privacy, opening up new possibility across various industries. And we will see how we implement our framework on AWS cloud environment. Now, let's see how to start implementing federated learning, so-called FL. So first of all, we have to identify the use case. In the financial sector, federated learning is revolutionizing credit risk assessment, fraud detection, and personalized services. So banks can now collaborate on model training without compromise sensitive customer information. And it's leading to more accurate risk evaluation and improved services. And the healthcare industry is another major benefit. Federated learning enables hospitals to jointly develop disease prediction and diagnose models without sharing low patient data. This approach is particularly valuable in genetic research for disease like cancer and Alzheimer's, as well as in advancing personalized medicine and facilitating collaborative medical research. Okay, so to implement federated learning, we have two main options for computing resource. One is a public cloud platform. Public cloud platform offer the flexibility and scalability needed for handling large-scale distributed data processing. So alternatively, For organizations with strict data security requirements, on-premise infrastructure can be utilized by installing appropriate software and federated learning framework on existing servers. So as privacy regulation tightens and the demand for AI model accuracy increases, federated learning is ready to play an increasingly crucial role in the future of AI development. It's an exciting time to be at the forefront of the technology, and I look forward to seeing how it will transform our industry in the coming. So, in this page, I would like to discuss some key aspects of modern cloud architecture and DevOps practice that are essential for building and maintaining robust, scalable, and efficient cloud-based system. First, let's talk about infrastructure automation. And it's by leveraging infrastructure as a core, we call IAC. We can manage and provision our IT infrastructure through core rather than a human manual process. This approach significantly enhance efficiency, consistency, and repeatability in our deployment. And next, we will explore deployment pipeline, a crucial component of CI and CD process. This pipeline automates the entire journey from core commit to production deployment, encompassing steps like building, testing, and deploying core. And we will then delve into the practical configuration of compute, networking, and storage resource in the cloud. This involves selecting appropriate computing instance, setting up network security groups and routing, and configuring suitable storage solutions based on specific requirements and best practice. And next, debugging its cloud environment is another critical skill. We will discuss techniques and tools for identifying and resolving issues, focusing on monitoring application behavior and performance. And login and metrics correction are another two more important aspects we will cover. Systematic logging of information from applications, servers, and other IT components is crucial for troubleshooting, security audits, and performance analysis. And similarly, correcting and analyzing various performance and operational metrics help us monitor system health, identify potential issues, and optimize performance. Okay. Before we introducing the federated learning architecture on AWS, I would like to present an overview of the AWS global cloud infrastructure. Currently, AWS has a global presence with 34 regions and 108 availability zones worldwide. Our customer can choose the most suitable or nearest AWS region based on their location. Therefore, when we conduct Flower federated learning, regardless of your geographical location or the location of other participants, this can be easily achieved through the AWS global infrastructure. You no longer need to prepare on-premise machine in different geographical locations. AWS can accelerate the progress of federated learning. And furthermore, AWS regions offer low latency, low packet loss, and high overall network quality. This is achieved through a fully redundant 400 gigabit fiber optic network backbone. So all data traffic on the AWS global network, which connect data centers and regions, is automatically increased at the physical layer before leaving our secure facilities. So let's see how we implement Flower framework deployment on AWS Cloud. This is a architecture diagram is illustrating the application of Flower federated learning in the AWS cloud environment. This diagram just primarily demonstrates life in the AWS environment. So you can have multiple federated learning participants as shown in the red bars on the left side. So while the right side represents a server end, the connection between them is established through a fully increased private network. On the left side, each participant have its own independent AWS account. By default, AWS accounts of different participants cannot intercommunicate, and their networks are isolated from each other. This setup ensures that each participant can maintain proper data protection and network security when using the AWS environment for Flower federated learning. So the isolation between different AWS accounts guarantee that each participant can securely engage in federated learning in their own environment, while the increased private network allow for safe communication between the participants and the server end. This architecture emphasizes the importance of data privacy and security in federated learning implementation on cloud platform. So in this page, I have just list 5 items here, which are most basic AWS services and resources we need to consider when starting to build a Flower federated learning environment on AWS. This includes a unique AWS account environment for each federated learning setup, security protection, storage space for training data, network environment design for participants and the server side, and the most importantly, a fully managed machine learning service to help you accelerate the deployment of federated learning. So in the following presentation, I will explain each of these 5 important items separately. First, I would like to introduce AWS account management to you. When our customer want to perform Flower federated learning on AWS, they will, by default, each have their own AWS account environment, which is represented by the red boxes in the diagram on the right. Each AWS account is an independent tenant environment, isolated from each other by default, and unable to communicate with each other. This is primarily to ensure security and compliance in cloud usage. So when using an AWS account, you can deploy corresponding security, storage, network, and machine learning environment in it. This is AWS account. And that's in AWS, we always think security is the top priority. So here I would like to walk you through the key aspects of AWS security, identity, and compliance. Our approach is comprehensive, covering 5 critical areas. First, we focus on protection. We employ advanced techniques like encryption, user behavior analysis, and the content identification to safeguard your data. This forms the foundation of our security strategy. And next, prevention is crucial. We help you define user permissions, secure your infrastructure, and implement data protection measures. This proactive approach ensures a smooth and planned adoption. And detection is also important. We provide tools for logging and monitoring, giving you a clear understanding of your organization's security posture. This allows for effective incident management, testing, and audit. And when incidents do occur, our response capability come into play. We automate incident response and recovery process, allowing you a security team to focus on root cause analysis rather than routine tasks. And finally, we emphasize remediation. Our event-driven automation enables you to quickly patch and secure your AWS environment, in near real time, minimize potential damage from security breach. So by implementing these 5 pillars, protect, prevent, detect, respond, and remediate, we create a robust layer security approach. This comprehensive strategy not only protects your assets, but also enable your organization to innovate with confidence in the AWS cloud. So when it comes to security and compliance, it's inevitable. Next, I would like to discuss the crucial concept of shared responsibility in AWS cloud security. At its core, this model defines security duties between AWS and its customers, creating a collaborative approach to safeguarding cloud resources. AWS take charge of the security of the cloud, which encompasses protecting the underlying infrastructure. And this includes hardware, software, networking, and physical facilities that power AWS service. Essentially, AWS ensures the foundation of your cloud environment is secure and robust. On the flip side, customers are responsible for security in the cloud, the blue one. This involves securing everything you build and run on top of AWS infrastructure. The extent of your responsibilities depends on the specific AWS services you use. For instance, with Amazon EC2, you are in charge of managing the operating systems, applications, and security groups. However, for more abstracted services like Amazon S3, your focus shifts to data management, access classification, and access control. This shared model just offers 2 key benefits. First, it reduces your operational burden by letting AWS handle infrastructure security. Second, it provides you with the flexibility and control to tailor security measures to your unique needs. Remember, cloud security is a partnership, and understanding your role is crucial for maintaining a secure AWS environment. Okay, so remember, in the world of cloud security, less is often more. Less is often more. By limiting privileges, we enhance our overall security posture and protect our valuable assets more effectively. So in the architecture diagram, assuming we have 2 AWS accounts, participant A and the server. In the participant A's account, within an Amazon SageMaker instance, running a Federated model within a private subnet. This Amazon SageMaker instance is AWS managed machine learning service. We call it SageMaker, and we will explain its more details in the next session. Okay, so the server account also has a SageMaker instance, but it's running a global model in the right side. Okay, so the key to implementing this privilege here lies in the careful use of IAM laws. By creating specific IAM laws with limited permissions, we can control and restrict the communication between these 2 environments. This approach allows the server side to interact with the machine learning environments of participating, but only to the extent that it's absolutely necessary for the task at hand. Why is this important? Well, by minimizing the privileges and access rights, we see we can reduce the potential attack surface. If a security breach will occur, the damage will be contained due to these strict limitations. Moreover, this setup enables collaborative machine learning projects where maintaining strong security boundaries and the Federated model in participant A account can contribute to the global model without exposing unnecessary data and granting excessive permissions. Okay, so in this page, I would like to introduce you to Amazon S3. This is a fundamental service for storing your machine learning training data. Amazon S3 is not just any storage solution. It's an Aperture storage service. Let's list the industry in scalability, data availability, security, and performance. So one of the most impressive feature of S3 is its durability. It's designed to deliver 7 nights. So the durability is very high. It just measure your data durability. So this level of reliability is ensure your critical machine learning training data is always accessible when you need it. And now let's talk about how S3 integrate into a typical machine learning workflow. As you can see in our diagram, we have an on-premise setup. Okay, we have setup with the database or storage containing training data. Okay, this data can be transferred to S3 through various methods, the AWS API, AWS Storage Gateway, or via Internet, IPsec VPN, or AWS Direct Connect. Once in S3, your training data is securely stored in your AWS account. From there, it can be accessed by Amazon SageMaker instance running in the private subnet, where your Federated model can be trained and refined. This setup not only ensure data security, but also provide the flexibility and scalability needed for modern machine learning projects. Okay, let's walk through an AWS network design. Okay, our design, I will showcase a powerful correlation setup within using Amazon SageMaker. So this design feature 2 distinct AWS accounts. One is a server and another is a participant. At the core of our architecture, we have a virtual private cloud we call VPC in both accounts. These VPC are interconnected via VPC peering, enabling secure and direct communication between the server and participant environments. So in each VPC, we have established private subnets to host Amazon SageMaker instance. And these instances are the powerhouses where our machine learning magic happens. And the isolation provided by private subnet add an extra layer of security to our sensitive data and computations. And let's talk about networking. Our VPC is virtual private cloud are configured with IPv4 addressing. And it's crucial to avoid IP address conflicts between the participants and the server. So, and to facilitate internet accessing for our private resource, we have implemented Net Gateway for seamless integration with S3. And we utilizing VPC endpoint just allow direct and secure access to S3. Okay, so here I would like to quickly introduce Amazon SageMaker to you all. It's a high performance, fully managed infrastructure that can scale up or down your computing resource through the most widely used compute optimized and GPU accelerated instance in the cloud. And Amazon SageMaker offers you a comprehensive suite of machine learning resource and service. Here we recommend using SageMaker notebook instance And its advantage is the ability to launch a fully managed Jupyter Lab from Amazon SageMaker Studio in just seconds. And SageMaker Studio also comes pre-configured with the SageMaker distribution, which includes popular packages for machine learning, such as deep learning frameworks like PyTorch, TensorFlow, and as well as popular Python packages like Pandas. And in our next session, we will provide a more detailed explanation of how to apply flower federated learning in Amazon SageMaker. Okay, finally, let's take a look at the key takeaways from the presentation. We know nowadays federated learning plays a crucial role in fields such as finance, healthcare, and the IoT, Internet of Things. And to enable model training while safeguarding sensitive data, and with the AWS cloud environment, it can provide robust support for federated learning, including infrastructure, flexible allocation of computing resource, and storage, and comprehensive debugging and monitoring tools. So when you implement federated learning on AWS, each participant requires an unique, independent, and network isolated resource environment. It's just equipped with strict security and compliance configurations, as well as network and permission control, and Amazon S3 as a storage service for machine learning training data. Okay, so this is about the architecture overview on AWS. I hope you enjoyed this session. And next, we will have Ray Wang to share more insight on AWS managed machine learning service. Okay, so that's about my presentation. Thank you.
Thank you, James. We've got a couple of questions before we go to Ray. Let me just run through them with you. First question is the SageMaker instance a VM or a container? Yeah.
Okay, this can be a VM, virtual machine.
Okay, got you. Okay.
It's a virtual machine, and but we have a built-in container like a PyTorch, TensorFlow, or some image already built for you, which you can quick start your environment.
Excellent. Sounds very good. Next question is, it says, hi, in the AWS architecture presented, are the participants assumed to be running in the cloud? And traditional federated learning training typically happens on edge devices. Could you clarify this point, as I might have missed something?
Okay. James, will you answer this question, or?
Okay, you can take this question. Right.
Okay. Actually, for the we will suggest the server side can hosting on AWS environment like a SageMaker notebook, which help you to quick start. But for the client side, you can host in the your on-prem environment, which is only if you can connect to AWS environment. So it's okay for you to have a hybrid architecture, have your training data and your training job in the on-prem, but your server on AWS. We will cover this a little bit more in my session.
I must just also say that we've at Flower seen a number of cases where organizations are connecting different cloud instances together using federated learning. So they might have a separate AWS, I'm not sure the term, but like, a workspace or that's controlled by one organization, and then they might have another one controlled by another organization, and then the aggregation server might also be hosted in Amazon as well. It just depends. The data in those cases is isolated deliberately, and so this is one way to easily connect them. We have another question. Will we be having a hands-on tutorial about deploying FL across multiple AWS EC2 instances in the webinar. I don't believe we had one planned, and I'm afraid we won't be able to just quickly build one up. So I guess the answer to this is no. But I do know my colleague Javier was putting one of those together. And so I'm not sure if you folks in Amazon have such an example, but we have one that we could show if there's interest. So Manso, if you just reach out to us later, we can show you this example, or if anyone else wants to, just we can always hold another of these sessions and show this example of how you can combine different Amazon EC2 instances. Quite a few questions here, but one more question. Question says, I'm currently deploying an FL pipeline for predictive maintenance using AWS and Flower, where training logic runs on edge devices managed by AWS Greengrass. This is based on an AWS article I've been following. Oh, I see. It's just that it's more of a statement. They're just describing their scenario. Oh, it's a very interesting scenario. It's cool. Okay, cool. Well, we're running a little bit late, I think. So let's go to Ray Wang's presentation. Yeah, thank you so much. We're really looking forward to this presentation. Over to you.
Cool. So hello everyone, I'm the senior solution architect working in AWS Taiwan, and I mainly focus on the analytic and the machine learning, also the federated learning part. And I will covering several considerations, which when we have our Flower framework and federated learning on AWS and especially Amazon SageMaker, how we can approach it, and why we chose to approach it in this situation. And first of all, the James part already covered. We have two very important components. One is server, and the other is client. For the server, we will distribute the global model to each client, and each client will training the model through their local data and update the gradient to the server. And the server will aggregate the gradient and update the parameter and the weight to each client to finish several rounds of the training process. And then you can have a global model. Like others, we have someone ask about, we can have the training job in the on-premise or in the customer data center and we can also have the AWS Cloud Flower client. Just make sure you have a network communication, like you can build a VPN connection during your server side and the client side you want to join the federated learning, and make sure the permission is allow you to talk with each other. The network part is okay, and you can make it even in the hybrid environment. Actually, some of the customer in Taiwan, they have some policy to only allow their data locating their own data center. They were using the approach like the diagram I just show you. They have the on-premise environment, and they have a hybrid architecture to train the federated learning model. A lot of people may compare the federated learning with the distribution training, which I want to clarify how they are in common and how they are in different for. But when it comes to the distributed training, we have several different approach, and I will highlight what they are different from each other. Like for the data parallelism, we have the parameter and we have the data, but we may have several different rack or different GPU device, and different GPU devices will hosting part of data, just like a federated learning. You hosting different data in each Flower client, federated learning client. And during the training, they were using those data to update the parameter and calculate the gradient for in their GPU device. And when they doing the forward propagation, they need to aggregate the gradient from each GPU device or each different rack, and then they get the aggregate gradient, and then they will update the aggregate gradient to get the new parameter, and the new parameter will distribution to the different rack and different GPU device. After finish several rounds of the training, they will get the new model. And we also have the model parallelism, which when you're handling a lot very large model like the GPT or LLM model, and you need to hosting the model in different GPU because you don't have enough GPU memory in just one GPU. And we can also have the zero redundancy. When you trying to coordinate different GPU device, and you will have some situation like a GPU is waiting for others to finish some job. The zero redundancy basic idea is to minimize the waiting time for GPU device waiting each other. And then we can have the pipeline parallels, like we can hosting the different model layer in different GPU device. But when the distribution training, which very similar like the federated learning, is the data parallelism. Like the architecture show you, each GPU device or each device hosting part of the data, and we will aggregate it in each round of epoch. But when it comes to the federated learning, there is some make some different for the same part is like the last slide I show you, but the different part is when we come to federated learning, it can come from coordinated the Flower client from the multiple region. And they always come with the different business unit or different have their own AWS account or even in different data center. So the data is decentralized from the beginning to the end. But for the distribution training, they want to resolve the problem like they have they have a lot of training data, so they will just try to parallelize the training data. So they want to minimize the network communication effort. So they are usually in the single region or single account. So the data is centralized at the beginning. So when it comes with the cloud, you can have your server account and the client account in the same region to and connect with the network peering with each other. And we were using the backbone network to communicate with each other to minimize the network communication effort, which is very good news when you trying to do the distribution, trying to do the federated learning. And the AWS machine learning stack come with 3 different layers. The first layer is AI service, like you can have a computer vision, AWS building a model for you, you can directly using, and you can have the business situation like demand forecasting or personalize your search engine, some very special use case. And we also have some customer with data science team. So they wouldn't using a turnkey solution like an AI service. They want to customize their model. In this case, they were using SearchMaker. And when they're using SearchMaker, they can have their data prepared and the feature engineering and algorithm developer in notebook in the training model and deploying model. Only end-to-end and the CI/CD process can be handling in the Amazon SearchMaker framework and the service. For customers who already have experience data science, and they can directly using AWS GPU and and also the ML chip developed from AWS like Inferentia or Trinian, or directly using the deep learning model, which is optimized for our underlying computing resource. When you're using the Amazon SearchMaker, you will directly using the container which deep learning AI might building support. So the Amazon SearchMaker is trying to resolve the machine learning end-to-end problem. Like when you building your model, you need a Jupyter notebook, which you can have the SearchMaker notebook. It's a management Jupyter notebook. You can quickly experiment and writing code on it. And you can train model from to using service like a SearchMaker model training, which I will elaborate a little bit more, and covering some very interesting feature like a spy instant. And you can deploy your model directly in SageMaker deployment service, but you can take a different strategy, like you want to batch processing your request, our real time, or just processing the request in real time. According to different strategy, you will have different cost model for you to get the cost and the performance balance. And you can also monitor your model performance with the SageMaker, which we will in short is the machine learning operation end-to-end in SageMaker. So in SageMaker, different process we have a lot of different feature to fulfill different scenario and the customer requirement. Like when we prepare data, we will have some data wrangler to doing the ETL. We can directly writing the ETL code in the SageMaker notebook, which I will covering in a later part. And so the SageMaker notebook is you can take as a server because you're writing the code to run the server, and then you let the client to run the SageMaker management training job and communicate with the server. And then you can have your federated learning in SageMaker. And then after you get a model, you can deploy it directly in SageMaker. So how the federated learning like a flower happen in the SageMaker end-to-end will looking like this architecture. First of all, you will have just focus on the right-hand side. You will have the SageMaker server running in the notebook. In the notebook, which is a virtual environment, you have a container, which is a Jupyter kernel. We building support like PyTorch, TensorFlow, or scikit-learn. You can directly in the virtual environment running a Flower server and running a Flower server, just writing the evaluation code. And you can, after the Flower server is run, you can ask your client to run in the training job. They also develop their training job in another notebook, and then you can start a training job, which you writing code in notebook, but the execution the training job in the SageMaker model training service. And then we will have the parameter and the communication with each with the server. So we were writing the server address in the training code and let the environment to try to communicate with the server. So the network traffic is through the VPC peering, go through the gRPC connection. And then after several rounds of the model training, show your private data and your server evaluation data set, something like that. And then you can get the global model. Let's start with the SageMaker notebook instance. We can directly create a Jupyter notebook with just one click, and you can get a Jupyter notebook environment. You can write in your code in the environment, and you can share or collaborate with your team member and trigger the training or deployment directly from the notebook. But always through the SageMaker SDK to communicate with the SageMaker API, and you will get the virtual infrastructure, have a model training and the deployment in the SageMaker. So we can do a lot of things in the SageMaker notebook because we can directly interact with the SageMaker API through SageMaker SDK. So we can we can open in the Jupyter environment and writing some code like the screenshot show you. You can have your folder and your Jupyter notebook. And we can also prepare and process data, like we can sampling the data using SMOT, and we can check the imbalance, data is imbalance, or the data status, and to doing simple ETL with the pandas. And then we will upload the training data set to the S3, which in the client side. And we will also have the we can also have the model training in SageMaker. And before we start the model training, we need to have a server start. And in server side, you need to write in your evaluation function, like how when the gradient and the weight is updated into a server, how you will update the gradient. After the function is ready, you can have your Flower server initialized, and you need to tell the server how many clients will join the federated learning, and then the strategy which you define, and which is the server address, which is the SageMaker node. Because we're using SageMaker notebook as a server, so you will tell the Flower the server address for your SageMaker notebook. And then we can have and then we can start working on the SageMaker training job as a client. The thing we need to pay attention is we need to let two network communication with each other. So like James has mentioned, you have running your training job in specific subnet, which is a network environment, and you just have a VPC peering between those two subnet, and then your client can communicate to your server. And you also need to check the security group, which allow each resource in the subnet to communication with each other. When we helping customer to doing the federated learning, they usually encounter some challenge or some problem, like they have the network access problem or security problem. Just check your subnet and the security group will be helpful. And then we will have the SageMaker SDK, and then after our SDK just ask the SageMaker to fit the model. They will create a SageMaker training job under the hood, and the training job will print the log in the console, and we can also find the log in the SageMaker AWS console. And after we finish after the training job is start, they will communication with the Flower server, and then finish each round of the epoch and finish the training. Like we ask the training job and the server to do 3 rounds of training, and the clients that we have after finish 3 rounds of training, we will finish the federated learning training. Like the screenshot show you, the Flower server just start and waiting for the client to connect to the server. And after we have one client, and after one client is connected to a server and finish each round of the feed process, and we will get the model for after the federated learning and training on the SageMaker. There is one, so the SageMaker training after trigger from the SDK, we can doing a lot of things, like we can also scale a lot of the training node, or we can have the hyperparameter auto tune in the SageMaker model training, and we can monitoring the metrics is different and how the gradient is changed, and we can also benefit from the cost optimization strategy. SageMaker support a lot of framework. When we conduct the federated learning, we just choose the framework which is support both by SageMaker and the Flower, and then we can rewrite the training code and or just overwrite the evaluation function in the client Python file, and then you can have the you can directly have your client training code running on the image like XGBoost or scikit-learn image. But when we suggest customer to quick start, we usually suggest customer to using the framework they are familiar with. Our choice the machine learning framework, which is low level of implement effort, because the customer can quick start. And when we starting to training the SageMaker model on the SageMaker, we can really benefit from the management smart training. Like a lot of people can image. So the cloud provider like AWS will have a lot of instance, a lot of machine and VM. In sometimes we provide the the instant in special price, which we call spot instant. For the spot instant, you just provide the cost you are willing to pay for specific instant type, and then he will giving you the resource after you bidding and get the power compute resource. But sometimes the computer resource will get revoked, like other people get provide a higher price. So you need to persistent the model or persistent the process in each round of your training, and then you can you can just restart from the checkpoint you save for each epoch. So for the model training on the client SageMaker training, you can really benefit from the spot instant, and then you will follow the process of the diagram I just showed you. But one very important part is the checking point you need to save during the epoch you just training your model. After the model is ready, you can have the SageMaker model deployment to deploy the model. How it really works is basically it's basically based on the image, which like your model is training on the PyTorch or TensorFlow or Scikit-learn, and you're using the you get the model artifact, and you can have the model hosting with the same image like you training. You can create an Amazon SageMaker model based on specific image, and loading the model after your image is ready. And then you can have a configuration and endpoint to have several like auto scaling, several deployment resource you have in the SageMaker. Well, we also have a different deployment option. For better cost performance, we usually consider the batch rather than real time, because in batch scenario, we can process a lot of requests, and in real time scenario, we usually need to handle something like load testing and make your inference resource auto scaling to handling your user request from demand. So the batch process will be more cost efficiency. Just consider this option when your scenario doesn't need your request being handling in real time. And then that is also very important for the CloudWatch part. When we have the model training our deployment, we can have our metrics like model performance, or like latency or the accuracy during training, or the confidence score during the deployment. We can have those metrics, have the CloudWatch. You can have a you can collect those metrics, have monitoring, and take action when when your model performance degradation, when the data scenario is have bias or different from before, you can start to retrain the model. And when it comes to the federated learning, we can have the federated learning ops like ML ops we will consider. We start from the training code for the server side, how server side aggregation the gradient, and how the client side run the training job. And you always start with the federated learning server, and then you can have the notification or auto trigger the federated learning client to start a training job. It really depends on when the different company or different BU join your federated learning process, will they prefer to trigger the process by themselves, or they will willing to trigger by the federated learning server? If they're willing to trigger them by the federated learning server, they can have the process like what I show you. And after finish the whole process, we will get a model and the registry on the model card, and to sharing a model to people really join, have the access to join the federated learning. Okay, and then we will have the takeaway part. We always need to choose the algorithm supported by the Flower and the SageMaker, and Flower is very easy to use because it's a framework agnostic, and you can using the framework supported by Flower, which you also familiar with, which make people it's easy to quick start. And we can start to prepare data, writing the code in the SageMaker notebook, and training the model with a Spot instance if you want to do cost optimization. And then you can deploy the model using SageMaker model deployment and the monitoring model training and deployment with CloudWatch. Also, further consider the Flowers Federated Learning Ops guide for the federated learning operations on AWS. Today, I share a lot of screenshot and code, and you can find the code in the workshop we already published in AWS workshop website. You can scan the QR code to get the workshop directly in the public website, and you can try it directly on your Jupyter environment with SageMaker exclusion rule or permission. Yeah, this is the end of the my sharing.
Thank you, Ray. That was a great talk. There's a lot of interesting practical issues that I think people are going to face when they roll this out. We've seen them come across many times, and I think you've answered a lot of questions there for folks. If anyone wants to ask some questions, we're happy to take them now. Yeah, we can just raise your hand or post them in the chat, or we can have a look in Slack, see if anyone's got questions in the Flower Slack. Yeah, I do see one. It's just a simple one on the Slack. They're saying, can you say a few words about a deployment you've been involved with in Federated Learning as an example? I can understand why they're asking this, but I understand also there might be some sensitivities with businesses and so on. But could you give us some, some hint or some anonymized example?
Okay. So when it comes to the federated learning model deployment or inference, customer always start with the real-time deployment, like they want the model to process the request as soon as possible. But when we discuss with customer, like customer in finance or Telegram, we usually ask customer to considering the cost of that model inference in and processing real time. At the discussion, a lot of customer were using some scenario like the fraud detection in batch process because they don't need the model to process the request in so urgency, and they want to consider the cost and to make it balance. So we were following the diagram to let the model to choose the right deployment option for the customer scenario.
Makes sense. Well, obviously, if they put it into batch, they can save quite a bit of money.
Yeah.
Okay. Awesome. Great. Well, I don't see any other questions. I guess we've answered quite a few questions up to this point. So I guess I will just share my screen for the final slide of this event.
Cool.
And that is that's just to say thank you to everyone who has attended. We were delighted to share with you these different talks by the members of the AWS team that we've been working with based in Taiwan. They're doing great stuff and they're great people to work with. And also the members of the Flower team who presented some other slides about Flower and use cases. If you want to reach out to people in this that you've heard from in this workshop, here is some contact information there. You'll notice on the right-hand side, we've listed the Amazon email addresses of everyone who presented. You see the email addresses of Nadia, James, and Ray. And on the left-hand slide, there's a QR code for joining Slack. And for Flower, that's the best place to go to get support. But also, if you want to reach out to us via an email, for example, we've got our generic email address there if you need to reach out to us. So this is it. Thank you so much for joining us. There'll be a recording of this made available. But yeah, thank you all for exploring the use of federated learning. We think it can do wonders for your enterprise use case. Take care and have a good evening, morning, or afternoon. Bye-bye.